What if I told you a robot could learn to play chess, drive a car, or even make stock market decision without ever being told what to do? Just by learning from experience like humans. Sound magical, right? Well, that's exactly what reinforcement learning does. Let's decode this powerful concept together in simplest way possible. Hello learners, welcome back to Data GPT, where we make tech simple, clear and super fun to learn. Today's topic is one of the most exciting area of artificial intelligence, reinforcement learning or RL for short. This is the technique behind game-winning AIs, self-driving cars and learning robots. So if you ever wonder how machine get smarter by their own, this video is just for you. And hey, don't forget to like, share and subscribe if you are excited to learn more about AI. Let's start with super simple definition. Reinforcement learning is when a machine learning learn by doing something and getting feedback. Imagine you are teaching your dog to sit. Every time it sit on command, you gave it a treat. When it does not no treat, eventually the dog learns if I sit, I get a reward. That's a trial and error, and that's reinforcement learning in real life. In ML terms, the machine or agent tries something, it learns from outcome, and then it improves over time. It is different from traditional learning where we just show it data. So how does RL actually works? We need four main things. An agent. This is the learner like robot or software. An environment. The world the agent interact with, like maze, road, or game. Action, the choice that agent makes, like turn left, jump, invest, etc. Rewards, feedback, was it good or bad action? A positive rewards encourage the action, a negative rewards discourage it. The agent's goal is to maximize reward over time by learning which action gives the best result. It is just like life, we learn from success and failures. Reinforcement learning is not just a theory, it's used everywhere. Games. Remember when Google's AlphaGo beats world champion? It's learned purely from RL. Self-driving cars. They learn how to stay in lane, avoid accidents, and make turns by practicing in simulation using RL. Financing. Stock trading bots use RL to learn the best to buy or sell. Robotics. Robots learn to walk, pick up the objects, or do surgeries by learning step by step through rewards and mistakes. So, whether it's playing games or saving lives, RL is already shaping the future. Now, let's look at two types of RL: model based RL and model free RL. Model based RL. The agent builds a mental map of environment. It uses the map to plan ahead, like chess player thinking of 5 moves ahead. Great for strategic tasks. Model free RL. The agent has no map. It just tries things and learns through feedbacks, like a baby learning to walk. Lots of falling, but eventually success. For beginners, model free RL is good starting point because it is simpler and does not require simulating the environment. Here are some common algorithm used in RL. Q learning. Think this is like a keeping cheat sheet. It stores the value of each action in a table called Q table. The agent look at the table and say what is the best thing to do in this simulation or in this situation. Sorry. Tharsa, very similar to Q learning, but with a twist. It updates based on next action actually taken, not just the best one. Deep Q networks takes Q learning to next level by replacing Q table with neural networks. This allows it to learn from very complex environment like video games or simulation. Want to feature video on Q learning? Comment below. The agent improve through feedback. Do something positive feedback, get a reward. Do something bad, negative feedback, get a penalty. But it is always good. It is not always that simple. The agent always has to decide, should I explore new action? Maybe there is something better out there. Or should I exploit what I already know works? The balance between exploration and exploitation is critical. Too much exploration and the agent wastes the time. Too much exploitation, agent might miss better opportunities. RL is powerful but also challenging. Delayed reward. Sometimes agent does not know if its action was good until much later. Large environment. Imagine teaching an agent to play chess. There are millions of possibilities. Training time. RL often take a lot of time to learn, which make it computationally expensive. But with smarter algorithm, more computing power, RL is getting better every year. Now, let's compare RL with other machine learning algorithm. Supervised learning learns from labeled data. Its main goal to predict the correct output. Unsupervised learning learn from pattern in raw data. Its main goal is to group or discover pattern. And the reinforcement learning learn on the basis of action and feedback. Its main goal is to maximize reward over time. So while supervised learning is being told the answer in a quiz, unsupervised learning is like grouping things on your own. Reinforcement learning is like a learning through life experiences. All right, let's wrap up. Reinforcement learning is how AI learns like a humans through experiences, reward, and mistakes. It's already powering things like gaming bots, self driving cars, trading softwares, and robots. And it is just a beginning. If you like this video, please like, share, and subscribe to DataGPT. We break down tech so even beginner can master it. Drop a comment if you love a follow-up video on Q learning or how RL is used in robots. Okay. Thank you so much for watching. Keep learning, keep exploring. Bye bye.